Okay, in this presentation I want to give you a bit of a course overview. Most of it will be about what's on Exam 1, but then I want to give you just a hint at least of where we'll be going later in the course. Okay, so first of all, let me just say a couple of things about statistical software. You should have a TI 83 or 84. We will be using stat functions on that. If you haven't already done so, you should download R. I have a video on Blackboard under Statistical Software that shows you how to download R, and then there's a short video there, and you can and a Word document that has the list of the commands that I use in that video to kind of get you started there. Later we'll get to the R Commander package in R, which will make some things a little bit easier. Jump you should download from the disk that came with the text. And I also have a video up for that. SPSS, if you're on campus, could be a convenient program for you to use. It's pretty easy to use and pretty powerful. Let me come back and say R is free, and so if you just follow the steps in my other video, you can download that for free, and it can be used for any purpose. Then Microsoft Excel, I'll give you at least one add-in, maybe some others that will make that a little bit more usable for statistical analysis, especially for graphing and that kind of thing. And then at some point I might at least post a couple of videos illustrating SAS, another program that's used in a lot of companies. Okay, so Exam 1 is going to cover Exploratory Data Analysis, EDA, also called Descriptive Statistics. So first you need to get some handle on the language of statistics, the difference between a population and a sample, population being all items of interest, all people of interest, or all objects of interest, or whatever, and a sample being some subset of that population. Usually a simple random sample taken from that population. We'll have a little bit more to say about that later. Parameter would be a characteristic of the population, and a statistic a characteristic of the sample. You'll see some differences in symbols. For example, when we talk the average or the sample mean, that'll be X bar. That's what we'll compute in order to estimate mu, a population parameter, or the mean of the whole population. So statistics are computed from samples and are often used to estimate or test hypotheses about unknown population parameters. X bar used to estimate mu. Need to make a distinction between quantitative/numerical variables, just two names for the same thing, versus qualitative or categorical. I think in a later course that might be even called attribute variables when you take operations. Quantitative variables are things that are how many, how much, that kind of thing. And you can compute the means of those. So like miles per gallon or number of people in a classroom, you can compute averages of those. Qualitative or categorical variables, as the name suggests, you just put things into categories. So if you had the category, for example, male and female, then you couldn't compute the average of that, but you can compute the proportion or percentage in each group. So depending on whether or not you have quantitative variables or qualitative variables, will affect the kinds of statistics that you can calculate. So one of the first things we'll do is just talk about, and this is chapter 2 in your text, how to visualize a single quantitative or numerical variable. We'll have histograms. So in this particular case on the left here, in the class 0 to 20, you have 11 observations. In the class 20 to 40, you have 5 observations, and so forth. Now, one of the things we're going to look at for the histogram is the shape of the histogram. And that can be influenced by how you divide the classes. In this particular one, if we had, for example, 0 to 5, 5 to 10, 10 to 15, and so on, it would look quite a bit different from this. On the other hand, and I'll show you how in R to construct a density plot, that's going to be more likely to reflect the real shape of the sample. In a sample of this size, where I don't have that many observations, it's not going to make much difference. But in larger samples, that can make a big difference. And when you have a choice, the density plot tends to be a little bit more accurate depiction. of the data that you have. A couple of other things we'll do is just a box plot, where, for example, on this top one we have the lowest value. The edge of the box here will be the first quartile. That means 25% of the values, or 1/4 of the values below that point. Then the line in the middle will be the 50th percentile, the median. Then we'll have the third quartile, and in some cases you'll have some more values there. When you have circles right there, that's going to designate that we have outliers. We'll also talk about extreme values as we go along, which are just more than outliers. Then we'll have error bars here. In this particular case, the height of the bar right here would indicate the mean, and then the height of the line will indicate how spread out the data. In fact, this particular one, if I remember right, is plus or minus 1 standard deviation, which we'll talk about that in a little bit. If you're visualizing two quantitative variables, now, for example, you might have x and y, like you had lines when you took college algebra, and one of the things we'll measure from those is the correlation. And you can see in these top two, I'm going to have negative correlations because they're going down, and since this one's a little bit tighter, it's going to be higher. Same thing down here, except for they're moving up, so we're going to have positive correlations. Don't worry if you're not getting all this right now. We're going to go through this in some more detail as we move along. But again, the values are tighter to the line here, so the correlation is going to be higher. What I want you to get out of this is that we are going to look at one quantitative or numerical variable, get histograms and box plots, but we'll also get to two quantitative variables. That will be in Chapter 4, and the first exam will cover Chapters 2, 3, and 4. Here are just some other things. This is the same thing as Scatterplot, but now for each of the two variables, in this case a GMAT quantitative score, and then the first year of an MBA GPA, in addition to have the Scatterplot, I'll have on the in the margins here a box plot for the GMAT and a box plot for the GPA, just enhancing this Scatterplot a little bit. And then here, this is a Scatterplot, but different colors and symbols indicate different groups that you might have. For a single qualitative variable, we'll have bar charts and pie charts, and I'm going to, I guess, assume that you've seen this kind of thing before. This would just be the number in each category, more in this blue category than other categories. Well, I clicked a little bit too fast on that, but that's okay. Clustered bar chart, now I have like some characteristic, but then also I might have females versus males within this group, females versus males in this group, and so on. Of course, we'll want to label the axes and put titles on, and that when we get through it, but right now I just want to get you a general idea. Then a mosaic plot. Another thing for two qualitative variables. So we have one qualitative variable over here, business, big data, math, OR, programming, statistics, and then the skills of the people identified as they have in different areas. And so what we look at in here is like big boxes. So data researchers tend to view themselves as having a background in statistics, whereas data researchers, the blue is programming, don't generally view themselves as having a lot of programming skills. So we've had the visual summaries. Now we'll also have numerical summaries. So for one quantitative variable, we'll have the sample mean, which will be symbolized with an X by an X with a bar over it. The sample standard deviation, which will be symbolized by S. There'll also be the sample variance, which is just S squared. What I want you to get at here is that the mean is the center, the standard deviation is just how spread out the data are. I'll move down here to median and IQR. The median is just the difference between, in an ordered array, the difference between the 25th and 75th percentile. You'll see that in another video. And the IQR would be, the median is the middle value. The IQR would be a measure of spread, the width of the box on a box plot. And then quantitative variables, I kind of already hit that correlation coefficient when I had the graph with the scatter plots on it. And then we'll also, just like you did in college algebra, talk about the intercept and the slope. We'll have different symbols, but the intercept will be A and the slope will be B. And then we'll have numerical summaries for qualitative variables. For a single categorical variable, a proportion, and for two categorical variables, we'll have a cross tabulation. So, just in general, on exam 1, what we'll talk about is getting data from samples. We might have one quantitative variable, we might have two quantitative variables. We might have one categorical variable, we might have two categorical variables. For each of those, we'll try and, where possible, compute numerical and visual summaries of the data. And I know I moved pretty fast on that, but I just want you to get just the general sense of things. Here's a table, and I'll put this on Blackboard, that kind of summarizes the type of variables that you might have and the symbols and names for different parameters and statistics. That's something you'll want to kind of burn in early on, because it's not going to just affect exam 1. It's going to affect every exam for the entire course. You may notice that I left off two qualitative variables here. That really turns out to be a series of sample proportions and proportions, but you usually actually don't. That's one way to think about it, but we usually just talk about it as a cross-tabulation table, and more about that later. Again, parameters are characteristics of populations. We usually don't calculate those. We'd like to estimate them. Statistics we compute from samples in order to estimate those population parameters. So the sample proportion p hat is an estimate of p, the population proportion. X bar, the sample mean, is an estimate of the population mean mu. The sample correlation R is an estimate of the population correlation rho. Okay, exam 2, and again, at this point, not expecting to really understand all of this. I just kind of want to give you a broad brush picture of sort of the front of the puzzle box before you start putting the puzzle together. So in exam 2, we'll talk about some probability and probability distributions. The binomial distribution, which you should have had in QBA, is just if you have a yes-no variable and you take a bunch of samples, like if you flip a coin 10 times, what will the distribution of flips look like if you did that over and over again? Then the normal distribution, or bell curve, that will be the basis for a lot of things that we'll do in the over the course of the semester. Sampling distributions, this will be, and I'll just kind of put this out there right now, this is going to be a turning point in the course. Because now, instead of talking about the distribution of some random variable x, we'll actually take statistics like x bar and make graphs of what would happen if we continue to take sample after sample and compute statistic after statistic. So if we, for example, we might have a sample of size 50. We take that sample of 50, compute the sample mean. Then we take another sample of size 50, compute the sample mean. Then another sample of size 50, compute the sample mean. Well, if we did that over and over again, the distribution of those statistics, the sampling distribution, will be normally distributed. That's what I've got over here. Sampling distributions tend to be normally distributed. That then will become the basis of estimation. We'll have confidence intervals with margin of error. That's kind of like, well, actually it is exactly like when you watch the news and they say the proportion of people or percentage of people that in our polls favor a particular candidate, they'll also include a margin of error. So if someone had 52% stating they'll vote for them, but the margin of error is 4%, that means they could lose, because 52 plus or minus 4 will go from 48 to 56, and 48 is less than half the vote. Hypothesis testing will be based on the same kind of ideas, but here we'll ask something like, is the population, can we conclude the population mean is greater than 40? And so we'll test that as a specific hypothesis. What I want to just kind of, that's sort of basically everything on exam 2, but I want to also get the idea that before we can do those things, we'll need to obtain and calculate the appropriate statistics and draw the graphs, the stuff that we did on exam 1. So just by the nature of things, this course will be comprehensive. You have to do the stuff on Exam 1 before you can do the stuff and while you do the stuff on Exam 2. Exam 3, now we'll move to inference for review for one group, and then we'll add in two groups. So we'll have, we want to estimate or test hypothesis about the mean or the proportion. That's what we would have done on Exam 3. Then we'll add matched pairs, which would be just a pre-test, post-test, or before and after study. Then we'll have the difference between the means for two different groups and the difference between proportions for two groups. So this will just review and extend what we did on Exam 2 and actually on Exam 1 as well. So we'll still have confidence intervals and hypothesis testing. We're just going to go beyond looking at one group. So we'll want to know, for example, is there a difference in the mean miles per gallon for car A and car B? Is there a difference in the proportion of people that use your product for males and females? Would be a difference between two proportions. Again, I'm going to reiterate the pre-inference part. That is, we'll still have to have all that descriptive stuff, computing, obtaining and calculating statistics, draw the graphs, and so on. Exam 4, more inference. Now we'll talk about inference for three or more means. We had the difference between two means. Now we'll go beyond that to three or more means. The chi-square, you can think of, I'm kind of skipping there down to the chi-square, as extending the two proportion case. So crosstabs, we might have proportions from three groups or four groups, and actually it might be a little bit more than that even. Simple linear regression then will be inference for lines. So like we have a line is equal to intercept plus the slope times x. You can also think about those correlation coefficients, and we'll make hypotheses and estimates about the population correlation. A couple of things that we might cover. Sometimes I get to some of these, sometimes it just depends on how the semester goes. I'll probably post some videos anyway, so if you want to get some ideas there for maybe future interest, they'll be there for you. May do a little bit of forecasting. We'll stop that at just a moving average and simple time series kind of thing. So now we want to look over time to see if we can forecast maybe sales for next month or next year. At least post a video for you on statistical process control, just sort of like confidence intervals, well, turned sideways. It's a little bit different, but we want to know whether or not what we're making is within some tolerance limits. Multiple regression is just an extension of simple linear regression, except for now we're going to have our predictor y is equal to an intercept plus slope 1. You can think of it that way. It's not quite that. Slope 1 times x1 plus slope 2 times x2 plus slope 3 times x3. So now instead of just using advertising to predict sales like we might do in a simple linear regression, we would use advertising, amount of money we spend on research, the number of salespeople we have, and so on. So it just kind of goes in what I would consider a natural progression. And then ANOVA, what we'll do in the course mainly is there a difference between, let's say, three groups? But now what we can do with factorial analysis is, do those groups differ, but we'll have two things, maybe do different demographics and different groups differ. So that'll be just a two-way kind of thing, and it can go beyond that. And repeated measures would be if we computed the mean at time 1, time 2, time 3. Anyway, this is just some stuff we may get to in the last week or two of the semester. Come back now to just a graphical overview. So we've got our larger population, and then a sample that we draw from that. Of course, by producing data, that'll be some of the things that we do in some of our larger assignments, like take a survey, do an experiment, or whatever. But the basic idea was we have this larger population with individuals in it, and that population, which we may not even be able to define or obtain data from, would have population parameters. Then through some mechanism of collecting data. We'll get a sample from that. We'll get this data, do some exploratory data analysis, compute means, proportions, correlations, and that kind of thing. Then through probability, especially the idea of sampling distributions, that will allow us to do some inference, test hypotheses, or construct confidence intervals about those larger population parameters about which we can't really know. We can only estimate or test hypotheses about those. Okay, I know that was pretty fast, but I wanted to give you just a really, I guess it looks to me like about a 21-minute overview of the course.